work. Okay. The part of this that the Math 3 students have a hard time with is they're like, 45, 45, 90 triangle, what's that? And I'm like, you learned that in Math 2. And they're like, no, I didn't. I'm like, yes, you did. I'm teaching Math 2 right now. I just taught it. And they're like, no, I swear we didn't learn it. And I'm like, I swear you did. Okay, so 45, 45, 90, tell me what the three sides are. A, and then what's the other one? That was really discouraging. Whew, you guys. Whew, we are still in the unit for this. We have not even taken the test yet. We got some reviewing to do. Whew, okay. So here's 45 degrees, 45 degrees. We got A root 2. Okay. Then over here we got a 30-degree angle, a 60-degree angle, and a 90-degree angle. The 30-degree angle is across from what side? Ooh. A. Okay. Okay. The 60-degree angle, Jack. There we go. Okay. And then the hypotenuse is the 2A. Marvelous. Okay. So on the unit circle, we call it the unit circle because the radius is a length of 1. The radius is 1 unit. So here we have from here to the edge of the circle, this is a radius, and the radius is 1. All right. So this is also the radius. This is also 1. And this is 1. And this is 1. And this is 1. Now, if you look at your unit circle, we're actually going to start making labels now. What they did is they labeled all of these as points. Do you guys see these points? These are X's and Y's. They're coordinate pairs. So if you start here, this coordinate pair would be 0, 0. This is like right in the middle. So if we go up a length of 1, then what would this coordinate pair be? Not 1, 0. 0, 1, right? Because you got 0 for the X. We didn't go left or right at all. 0, 1. Okay. What would this one be over here? 1, 0. What would this one be over here? Negative 1, 0. And then what would this one be down here? 0, negative 1. Okay. Right over here, this is going to start at 0 degrees. And then what type of angle is this right here? This is a 90-degree angle. Okay. What does a straight line make? A 180-degree angle. Okay. So we've got 90 degrees. We've got another 90 degrees. That makes 180 degrees. If we do another 90 degrees, then how many do we have? 270 degrees. And then if we do another 90 degrees, we get a full circle, which is how many degrees? 360. Okay? So 0 degrees and 360 degrees are actually in the same location because you have the start of the circle, you have the end of the circle. So start of the circle is 0 degrees, end of the circle is 360 degrees. Okay. Does that make sense to you guys? Okay. So unit circle means that the radius is a unit of 1. Okay. So Jack, if you want it, since I didn't get one of these printed for you, you can just watch this part, and then later I can print one for you. You can fill it out. Okay. Perfect. So if we go back to this part, what we're going to do now is we are going to figure out how to fill in these coordinates right here. Does that make sense? Okay. So if this is 0 and this is 90, what's halfway between 0 and 90? 45. So this is going to be a 45-degree angle right here. And then these angles right here are going to be 30 degrees and 60 degrees. And so that's why we're going to reference a 30, 60, 90 triangle and a 45, 45, 90 triangle, because we are actually going to draw those triangles right here. And we're going to use those triangles to figure out what these lengths are, okay? And I'll show you in a minute how we're going to do that. So what we're going to do right here is we're going to draw a point right there. So that's the point on the edge of the circle. And that point is going to correspond with an x coordinate and a y coordinate. Okay, so here's the point right here. And what we're going to do is we're going to form a triangle, a right triangle. So we're going to take that point, we're going to drop a line straight down to the x-axis, and we're going to make a 90-degree angle. So now we have a right triangle. And the right triangle has two sides. It has a hypotenuse. And then for the other side, it has an x length. You can see along the x-axis, it has an x length that's going to correspond to this x value. And it has a height over here, a y length, that's going to correspond to that y value. Because along the triangle, you're going to be able to go over this amount x and up this amount y, and that's how you're going to get to the point. Does that make sense? Okay. Now, if you were to measure this angle right here would be 30 degrees. So this is a 30, 60, 90 triangle. Does that make sense? Okay. So the hypotenuse is 1. The hypotenuse of 1 corresponds to which side of this triangle? It corresponds to the 2A side of the triangle. So we're going to go back to that day when we did the special right triangles, and we're going to say 1 equals the 2A side. And then what should we do so that we can find the missing sides? Yeah. Divide by 2 to find A. So A equals 1/2. Do you guys see why this really fits within the Math 2 stuff? So around this point in Math 3, they're like, I have no freaking clue what's going on. But you guys, we've been doing this. So this makes a lot more sense to you guys than it does them because they're rusty. Does that make sense? Okay. So if A is 1/2, then what does Y equal? Y equals 1/2. If A equals 1/2, how could I find A? Oh, okay, so if I do 1/2 times √3, what do I get? 1/2 √3. How do we write that as like one fraction? We're not going to do decimals, so we don't need our calculators. √3/2 is how we write that. Okay, so we're going to say this is √3/2. So x equals √3/2. Okay, so now when I write this as an x coordinate and a y coordinate, I'm going to say that to get to this point, you would go right √3, and you'd go up, you'd go right √3/2, and you'd go up 1/2. Okay, so right √3/2, up 1/2. How do your brains feel about that? Pretty good? Okay, so we're going to go over here, and at 30, we're going to say right √3/2. Actually, these little lines kind of work really good as fraction lines. So we're going to say right √3/2, up 1/2. Now, if you look over here above the 180, it has that same 30-degree angle. It's just in the other direction. Everyone see that? So what's 30 degrees above 180? 150. So let's label this as 150. And then we're going to go left √3/2, up 1/2. So if we went left √3/2, then what should I do to the √3/2? Make it negative. So negative √3/2, 1/2. Okay. Now we have the 180. We also have this 30-degree angle, but it's just below the 180. So if we had 180 degrees, 210. 210 would be right below that. Does that make sense how we got 210 degrees? Okay, so if we took that same point and we went left root 3 over 2 down 1/2, what would the signs be? Okay, negative root 3 over 2, negative 1/2. Okay, over here we had 360 degrees. So if we went down 30, what would we have? 330. Okay, 1/2. Root 3 over 2, negative 1/2. Okay, so we got the first set of points done. Does it make sense where all of them came from? Pretty reasonable, okay? All right, brains are still good? Okay, let's move on to the next one. So the next one, we still have a radius of 1, and we still got the 1, the 1, the 1, the 1. So we're still talking about, let me label it on the bottom actually. We still got, well, I'm not going to label this one because we're going to do other labels. We still have the unit circle. We're still going to draw a point right here because this is what we're about to label. So we're going to have an x coordinate and a y coordinate. And we're going to do exactly what we did before. We're going to drop this line straight down. We're going to make a right angle. We're going to say this is the x, this is the y. So once we figure out these sides, we're going to say if you go over an amount of x and up an amount of y, you end up at that point. So x, y. And this angle right here is a 60-degree angle. So exact same triangle, it's just oriented differently. You guys tracking okay? Okay, so the hypotenuse of 1 still corresponds to what side? Still corresponds to the hypotenuse, so the 1 is still which side? 2a. So we're still going to say 1 equals 2a. And then we're still going to do what? Divide by 2. And we're still going to say a equals 1/2. Should we still say y equals 1/2? No, this time what do we get? X equals 1/2. Okay. And then what do we get for y this time? Root 3 over 2. So this time the y is the a times root 3. So we're going to do a times root 3. And that gives us root 3 over 2. And so y equals root 3 over 2. So our x coordinate is 1/2. Our y coordinate is root 3 over 2. Okay, brains feel good? Yeah? Okay, so we're going to take our unit circle and we're going to write 1/2 for the x coordinate and root 3 over 2 for the y coordinate. And then for this one, we have 90 degrees, so right over here we have 60. So if this is 30 degrees less than 90, what would be 30 degrees more than 90? 120. Okay, so to get this point, we went right 1/2 up root 3 over 2. So to get this point, we're going to go left 1/2 up root 3 over 2. So what do we have? Negative 1/2. Okay. Okay. And then we're going to do the corresponding points that are in the other quadrants, or what we call them. So down here, we have 270. What's 30 degrees to the left of 270? 240. Okay, so we're going to go left 1/2 down root 3 over 2. So we got left 1/2 down. This is 270. What would be 30 degrees this way? 300. So we have right 1/2 down root 3 over 2. So right 1/2 down root 3 over 2. All right. Brains are good? Okay, next one. I bet you guys can see where this is going. All right, what's our last one? What are we doing next? 45. This one's 45. Okay, so we've got a radius of 1. Got a radius of 1, radius of 1, radius of 1, because it's a unit circle, and that's what unit circle means. We draw our point. We got our x value, we got our y value. We drop a line straight down. Draw our 90-degree angle. X value, y value. So just a reminder, if we were to go over an amount of x and up an amount of y, we would end up at the point, and that's how we get the x value, the y value. So the 1, this is a 45-degree angle, the 1 corresponds to what side of the 45, 45, 90? Is it the A side or the A root 2 side? It's the A root 2 side. So we're going to say 1 equals A root 2. And then how do we solve for A to get these two sides? Divide by root 2. 1 over root 2 equals A. And it's not called solving. What is it called? Rationalizing. It's called rationalizing. So we're going to say 1 over root 2, we want to rationalize it so that it's proper. A mathematician said, no radicals on the bottom. That's not okay. We do not accept that. That's wrong. Terrible. Okay, how do we rationalize? Root 2 over root 2. Marvelous. And what do we get?
1 root 2.
Perfect. 1 root 2 over 2 is fine. People wouldn't write it that way, but it's not wrong. It's not wrong. It's just a little extra. Okay, so this is what A equals. And since it's 45, 45, 90, it's an isosceles triangle, which means that both of these sides are the same. So we got root 2 over 2, root 2 over 2. So your x-coordinate and your y-coordinate happen to be the same. Which makes sense because this one is smack dab in the middle. So if you think about how much you're going to the right and how much you're going up, it should be the exact same amount because it's exactly in the middle. All right, so 45. We're going to go right root 2, up root 2 over, right root 2 over 2, up root 2 over 2. Okay, so if you can see this, it's in the middle of 30 and 60, or you could say it's 15 degrees, whichever way the math makes sense to you. So you could either say what's in the middle of 120 and 150, or you could say what's 15 degrees away from 120, 15 degrees away from 150. So however you do the math, what number should be here? 135 is exactly right. Okay, so we're going to go left and up. So we got negative root 2 over 2, positive root 2 over 2. Okay. Then down here, either what's in the middle of 210 and 240, or you could say what's 15 degrees away from 210, 15 degrees away from 240. 225 is perfect. We're going to go left and down. So negative root 2 over 2, negative root 2 over 2. Okay. What's in the middle of 300 and 330, or 15 degrees away, 15 degrees away? 315. And we're going to go right and down. So root 2 over 2, negative root 2 over 2. Okay. We're going to add some extra labels in here before we finish our notes. Oh, zoom out, zoom out. Nope, zoom out. Zoom out. If I say it louder, it will know that I mean business. Zoom out. Zoom out. Zoom out. Listen to me. Aha. Ah. 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 No? The extra little lines are for the other types of measurements, because remember I said there's degrees and then there's something called radians. But you learn about that in Math 3, not in Math 2. So this is all the labels we're going to do. We're not doing any more labels. Okay? We're done. All right, so here's the other thing that I want you guys to put on here. You can do this in colored pen. You can do this in pencil. It doesn't matter. But this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Miss Rice, I don't like Roman numerals. Get over it. That's how they label them. So they go counterclockwise. They always start here at 0. So that's how you can tell if somebody is labeling something mathematically or if they're going like by nautical directions. Is mathematically, we always start here. We call this the positive x-axis, right? So it's the x-axis. These are the positive numbers. If you were going by like normal compass, a normal compass would start at north. Does that make sense? And then they would do their degrees from there. So if we're doing mathy stuff, we call this standard position, and we start over here. Make sense? And that's based on the unit circle. So you just learned it. This is where all our degree measures come from. Is we care in math, we care a lot about the unit circle. So you learned something very important in math today. If you're going to get a math tattoo, the unit circle is where it's at. No? No? Okay. So 1, 2, 3, 4. It's kind of nice to just remember which is positive versus negative x coordinates or y coordinates. So I like to write that in there. So it's positive, positive, negative, positive, negative, negative. I like to make this one a smiley face. No? Okay. Fine. Positive, negative. Okay. So usually advanced math students will have one really marked up unit circle that has like all the information on it, all the notes on it. You will probably in your math careers fill out multiple unit circles. So at some point keep one of them, maybe keep this one, put it in a sheet protector or something, because this will not be the only time you look at the unit circle. These are not the notes that at the end of the semester you have a bonfire and celebrate that you're done with math 2. Like you keep this one. Does that make sense? You burn the rest of it, you keep this one sheet. Okay? Right. Because this is not going away, it's staying forever. Forever and ever, amen. No? Okay. All right, so what I want you guys to do now is next to this, I should have put another circle, but next to this we're going to draw a circle. We're going to see how perfect your circles are. That's pretty good. That's pretty good. Good job, Miss Rice. I thank you, Miss Rice. Nate, don't draw an egg, draw a circle. So I'm just drawing the same shape that we've been drawing. Oh, very nice. I think Alex might win for best circle. Oh, very nice. Savannah, you can't hold it up to the light because then we notice that you traced it. You have to hold it up like with your hand under it or something. Ooh, very nice. Yeah, yeah.
It just came out of nowhere. You were like, oh, we're talking about ourselves.
So I'm gonna write r equals 1. I'm gonna label my x and label my y like I've been doing this whole time. And I'm gonna put my little theta over here. That's the angle that we've been using this whole time. Okay. Also, we are making very good time getting through the notes. So just an update. It's looking like test is going to be Thursday. First day of review is going to be Friday because we are not going to need a practice day tomorrow. Just a heads up. You guys are very good at this. Kudos. I'm impressed. You have impressed me. Good job. Good job. All right. So if this is the theta, let's write names for all of these sides. Not those types of names. What are the SOHCAHTOA names we've been giving the sides? Yeah. So what should we write? Y is opposite. X is adjacent. R is hypotenuse. Okay. So then we're going to go over here, and sine theta is opposite over hypotenuse. So in this drawing, the opposite is the y. The hypotenuse is the radius, which in the unit circle specifically is a length of 1, so it's going to be y over 1. Anytime we have something over 1, we don't really need to write the 1, right? So we're just going to say that sine theta is y. Sine theta is just y. So on the unit circle, sine theta is the y coordinate. Okay? So sine theta, what's theta? What does theta stand for? The angle, right? Okay, so I'm going to blow your mind a little bit. Are you guys ready for it? Yeah. Okay, so sine of the angle is the y coordinate. Okay, so if we go into degrees, sine 30 is 1/2. Sine 45 is root 2 over 2. Sine 60 is root 3 over 2. No? Isn't that cool? Okay. And why does it work, Miss Rice? This is the proof. This is literally why it works. I just showed you. This is why it works. We literally just did the math because this whole thing is the proof. You guys have literally just done the whole proof of why that works. Okay. So if somebody says, well, hey, why does the unit circle work? Say, let me get my Miss Rice notes out and I will show you. This is why I love the unit circle, because it's wild. Okay. So what we just saw is we saw geometry. This is geometry. You guys ready? This is geometry. And some algebra. This is algebra stuff. And they married together and they made truth. I don't know. Mind blown. Crazy, right? Do you guys love it? Was that fun? I don't know. I thought it was cool. Okay. So what we learned down here is that the y coordinate is sine. The y coordinate is sine. So down here where the y coordinate is, write sine. The y coordinate corresponds to sine. Okay. Cos. Adjacent over hypotenuse. So it's x over 1, which is just x. So, okay, let's do it again. We're going to do some magic again. So if we look at our unit circle, let's try another quadrant. So down here, cos of 210 is going to be negative root 3 over 2. Yes, that is true. Cos of 270 is 0. Yes, that is true. Cos of 180 is -1. Yes, that is true. Oh, you guys couldn't even see it. Okay, so cos of the angle measurement is the x-coordinate. That's what that means. We just did the whole proof so you guys could see why it works, okay? And it's because of special right triangles. So down here, we're going to write, okay, so in the unit circle, the x-coordinate corresponds to cos of the angle. Okay? Make sense? Yeah? Yes, Ms. Rice? Marvelous. Okay. Now, tangent is opposite over adjacent. So what's the opposite side? Y. Adjacent is x. So tangent is y over x, which is also the same as sine, because sine is y. X is cos. So tangent is the y-coordinate divided by the x-coordinate, which coincidentally is sine divided by cosine, which we explore later in Math 3. Okay, so we're going to add this to our unit circle sheet because we just uncovered some very big things. Okay? All right, so we're going to write this down. We're going to say the x-coordinate is cos. The y-coordinate is sine. I'm just putting it somewhere on my unit circle page. I just want to remember that. The x-coordinate is cos. The y-coordinate is sine. Okay? And then I'm going to write tan is y over x, aka sine over cos. Okay. So we're going to have to do some of these tangent ones because they're funky. They require some work. You have to actually like do some math to simplify those. So let's do some math before let's do some example problems before we get started on today's assignment. Sound good? Okay. All right. So keep your unit circle out. We're gonna do these problems down here now. So example 1. Okay. So today is calculator free. That means you have to take your calculator, you have to put it away. Bye-bye calculator. Okay. All right, so what we're going to do first is we're going to figure out, using only our unit circle, we're going to figure out what cos of 45 degrees is. Cos of 45 degrees. So on your unit circle, you're going to locate 45 degrees. So everyone look for 45 degrees. And then because it's cos, you're going to look at the x-coordinate, and that's the answer. So locate 45 degrees on your unit circle. Hold on, I have a little baby one for you. Sorry. Yeah, let's go for it. All right. So look for 45 degrees, find the x-coordinate. What's the answer? Root 2 over 2. Okay. Example 2. Sine of 300 degrees. Sine of 300 degrees. So we're going to locate 300. We're doing sine, so which coordinate are we looking at? Y. And what do we get? Negative root 3 over 2. Okay. All right. Let's try a tangent one. Okay, we're going to do tan of 180 degrees. So tan of 180 degrees, think about it. You have to do y divided by x. Y divided by x. It's going to be 0. So tan of 180 degrees, what numbers are you dividing? 0 divided by -1, which is 0. 0 divided by anything is just 0. Seth, is that a question? Just a stretch?
So tan is sine divided by cos, right?
Uh-huh.
Then 90 and tan of 90 and tan of 50 is infinity.
It's not infinity, it's undefined.
Yeah.
You'd say undefined. Yeah. So if we did, well, let's go ahead and write those. So we'll say tan 90 is y divided by x, which is undefined. Because remember what Siri says when you try to divide by 0? Can't do it. All right, let's do cos 135. Negative root 2 over 2. Okay, we're going to do negative sine. Negative sine, we'll see if anyone can figure this out. Negative sine of 210 degrees. Nate, what do you think?
Well, I just had a question.
Yeah.
The tan of 270 is also undefined, right?
Yes. Say it again. It'd be positive 1/2. So 210, sine of 210 is negative 1/2. So if I stick a negative in the front, it's going to be negative of negative 1/2, which is just 1/2. Does that make sense? Okay, I stuck a negative in front of the problem. Okay, let's do number 7. We're going to say this one is going to be tan. Okay, this one's going to hurt your brains a little bit. Are you guys ready for brain hurting? Tan 60 degrees. Tan 60 degrees. I'm gonna show you a tan. I'm gonna show you guys a tangent trick on this one. So we have y divided by x, right? So we have root 3 over 2 divided by 1 over 2, right? How do we divide two fractions? Multiply by the reciprocal. So this becomes root 3 over 2 times 2 over 1. What happens with the 2's? They cancel out. Okay. Now, all of the fractions have 2's on bottom, don't they? Like, in every single problem that has a fraction, they all have a 2 on the bottom. You guys notice that? So that is always going to happen. The canceling by 2's is always going to happen, right? So anytime we deal with this, we can ignore the 2's. Just ignore them, pretend they're not there. So with this problem, I wouldn't have seen root 3 over 2 over 1 over 2. I would have just seen root 3 over 1. When I do that problem, I ignore the 2's. All I see is root 3 over 1. That's all I see. If I see root 3 over 1, what do I see then? Oh, that's just root 3. Does that make sense? Oh, that's just root 3. That's easy peasy. So tan of 60 is just root 3 because the 2's are going to cancel anyway. Okay? Tan of 60 is root 3 because the 2's are going to cancel anyway. Okay? I'm going to show you one that's a little bit more difficult than that, though. Okay, we're going to do tan 30. Why is tan 30 more difficult? Because we're ignoring the 2's. The root 3 is on the bottom. So if we ignore the 2's, tan 30 is y over x. It's 1 over root 3. Even if I ignore the 2's, it's still a more difficult problem because it's improper. Does that make sense? So I'm still ignoring the 2's. I don't want the 2's because I know they're going to cancel. I don't care about the 2's. But it's 1 over root 3. So how should I fix it? Okay, I'm going to rationalize it, multiply by root 3 over root 3, and what do I get? Okay. With tangent, this is as bad as it gets. We just did the worst, well, aside from having negatives. You could have negatives in the problem. But we just did the worst possible combination with tangent you can have. So this is the most terrible tangent answer. Okay? Let's try another tangent one that could be bad, but you'll see that it's not. Tangent 45. Look at it carefully and see why it's not bad. I like Pete's reaction. You're close. It's just 1. Why is it just 1? Not because 1 is better than 2. It's the same number over itself. So the x and the y are exact same number. So again, I'm ignoring the 2's on the bottom. I know they're going to cancel. And so for this one, it's just root 2 over root 2. And oh, those are the same thing, so it's just 1. Okay. Is there a combination? So if you're looking at these problems, I think sine and cosine are easy. So we're going to ignore sine and cosine for a minute. Is there a tangent problem that you can imagine with any of these that you are intimidated by? So is there a tangent one we should do before I let you guys work on the worksheet? Tangent 315, tangent 210, tangent 360, tan 330, tan 150. Is there a tangent of any of those that feels intimidating that we should do together first? Yeah, so they're all the same. They're just going to be playing around with negatives, positives. Okay, so go ahead and pull the worksheet out. I want to do one of them so you guys can see how it works. Okay. So notebook paper people, this worksheet is going to be kind of obnoxious because you are going to have to write down all 4 problems on the notebook paper to be able to do it. But these are considered to be kind of like puzzles, and you're supposed to figure out which part of the puzzle does not fit. Okay? So if we look at this one, what is cos 30? Not negative. Positive. It's root 3 over 2. Okay? What is sine 60? Root 3 over 2. What is sine 120? Okay. And then what is cos 150? Negative root 3 over 2. So if we look at this one, the odd man out is cos 150, and so this is the one we're going to circle as being the odd man out. So this is the work that I should see on your paper, that you found all 4 of them, and that you recognize which one was off. Does that make sense? So you're kind of going to be able to check your work as you go, because if you have 2 of them that are off, then you know that you did the puzzle wrong. Does that make sense? Okay. Yeah, I suppose you could do that. So notebook paper people, you can just do, like, write the cross and then do 1, 2, 3, 4 answers. You could just write the answers instead of the problems and the answers. Okay, everyone understand what they're doing? Yes? All right.